Hey, and welcome back to the Attack and Defense series, Common Web App Vulnerabilities. Throughout most of this series, we're going to be using the Juice Shop vulnerable web application. It's got a lot of great examples. Today, we're going to be looking at basic SQL injection. To understand how SQL injection works, first we got to look at some code samples, and then we'll come back to how to exploit it. Because it's important to understand from an application security perspective how an application works before you can start thinking about the security of it. Follows for me. So let's take a look at our Visual Studio code. Here I've prepared some unsafe PHP code that is making an SQL query. So let's start from the top. What's it doing here? We're taking the username and password that's been submitted through the account login screen. If we go back to our Juice Shop here, here. If we go back to our Juice Shop here, we go to account and login. You get a sense for what that form looks like. So when I put in an email address and a password and hit login, it's going to go to the server side to a page that looks very much like this. We're capturing the username and password from the request, storing them into a username and password variable. Then we have our SQL statement here. We're going to select the user ID from the users table. And we're going to be selecting that user where the username equals our username from the form and the password equals the password from the form. As long as these two fields are both satisfied, it'll return the user ID with the row that has both that username and that password. So you understand if you put in the wrong password or you mistype the username, it's not going to find that user in the database. So it's going to run this SQL injection. It's going to run this SQL query. It's going to pass it to the database, and it's going to return an array containing the number of users. Should just be one. Now, if a user is found, that is, if the username and password both match in the row, we're going to get a successful login. If either of them don't match, we're going to get an invalid login. Now, it may not be immediately obvious to anyone who hasn't seen SQL injection before or hasn't played around with SQL too much, but the entry point here is where these variables have been placed into the statement, the username and the password. These are both user controlled as they come from the browser. You can imagine that if I put a regular username in here, it will look something like, and we know the usernames on Juice Shop are email, so it might look something like, here's my email address, and then my password. My great password. 123, because that's how you stay safe. So you can see how the string that I put in is going to be substituted where those variables were. Now hang on a minute. What if my password, for instance, had a single quote in it? Now, from a syntax perspective, we have a single quote that's closing this opening single quote at the beginning of the string. What happens to this one? Well, it causes our SQL statement to break, and it causes an error when the database tries to fetch this user. This is the beginning of finding SQL injection. If you can cause a database error with your payload, you're about halfway there already. After discovering that there's a SQL injection, we actually want to make a SQL statement out of our variable. So we have a single quote. We know we've closed this single quote. What happens if I put another single quote here? Okay, so now I have two single quotes at the end of my string. The SQL statement will see a happily closed string and then in unnecessary but open and closed string here. It'll cause the statement to be valid. So now we see that we're writing SQL. Let's add some more so that this always passes validation. Since we know that both the username and password fields are both wrapped in single quotes, we'll start over at the username. That way, we won't even need to enter a password. This is done by starting with our single quote and then adding some SQL statement that will always return true so that we don't have to have the password. So why don't we, instead of and, use or, and 1 equals 1. So what this says now is we're looking for the user where the username equals j.mate@forwardsec.com or true. Basically, return all users. Now what about this rest of the statement? Okay, now there may be ways, there may be configurations that allow MySQL to ignore that, but even better, we can add the beginning of a comment line. In MySQL, that's 2 dashes. Now you can see if I use this as my username, it's going to comment out the portion that's looking for the password, and it's going to return the user ID where the username equals j.mate@forwardsec.com or true. In other words, all users in the table. Now what if I wanted to log in as a particular user? Well, instead of or, I might use and. This way we're saying where the username is this value and true, thereby ignoring this password area. Now let's say I wanted to log in as the admin user. Well, from doing a little reconnaissance on the website, looking at some of the blog posts, you can see that the admin user, his email address is admin@juice-sh.op. So if we now use this as our username and just about anything as our password, we're going to get a successful login. Let's go over to Juice Shop and check it out. Here we are back in the Juice Shop login screen. So just to show you that this is a proper working login screen, I'm going to try to enter my username and a random password. We'll do password 123 and log in. We get an invalid email or password. What about if we use the admin's email address, which again is admin@juice-sh.op, and we'll try the same password. We get invalid email or password. Now let's try to use the payload that we've created by taking a look at our SQL. Paste that in. And remember, if we go back to our code, and remember, if we go back to our code window, this will cause the username to be this entire string, which because of this single quote and because of this dash, will add this equation and comment out the rest. Now when I log in, I'm granted access, and as you can see, if we look under account, I'm logged in as the admin at juice-sh.op. Not all SQL injection is this simple, but more often than you would think. This is a very classic example. Now let's go back to our code and figure out what the developers could have done to prevent this from happening. So here in our unsafe example, let me rewind time. This is our original script. It's taking our username and password variables and sticking them using string substitution, sticking them into our SQL statement. That's where the problem started. Here we've got our unsafe SQL statement. Unsafe because of the string substitution. Now you might be thinking, well, I could just blacklist the single quote character. What if I looked for a single quote character in the password username field and erased it or escaped it? That's not a bad idea, but it's not going to prevent all of the different attack types. There are still many scenarios in which an attacker can get through. A simple example, what if you're using double quotes? Okay, I'll escape the double quotes. Well, what if it's not a string that you're wrapping in single quotes? What if it's an integer? Ordinarily, you're not going to wrap your integers in single quotes. Let's imagine that our username is, for some reason, an integer we expect it to be. Now, our payload doesn't need to have the single quotes, and it'll actually still work. Right? So the best solution here is what's called a prepared statement. There's also parameterized statements. The two of them are quite similar to each other. We're going to look at prepared statements in particular. The other option is to use what's called an ORM, or an object relational mapping. So that's a separate piece of software, a framework that you install, and it allows you to do SQL queries without actually writing SQL. What a prepared statement does still gives you the power of being able to write your SQL statements, but, and don't get overwhelmed when you see this, I'll explain it line for line, but what it does is the string substitution for you in a safe way. See these question marks? That's where the magic happens. So let's go through here. Just like before, we're taking our username and our password from the request object, from the login screen. We're creating our SQL statement just like before, except instead of putting the username and password as the values here with string substitution, and without even using single or double quotes, we've added these question mark symbols. The question marks are an important symbol for the prepared statements which we're about to approach here. In PHP, the common prepared statements library is called MySQLi. So we're going to create a new instance of MySQLi. These are the parameters you need to pass for it. First is the host name for your database user, your database password, and then the name of your database. Then from that object, you're going to call the prepare method. You call prepare on your SQL statement, and it creates a statement object. The statement object has a method called bindParam. So we're now that we have turned this into a prepared statement, it has these methods and features where we can start binding parameters to our question marks. So the first parameter is a string that has one character for every data type from left to right in your SQL string. I have two question marks, one for username, one for password. They're both strings. And so here I have S and then S again. The first S is for username, the second S is for the password. And we're declaring that they're both supposed to be of the string data type. The next parameters here are each the variables that are going to be found and substituted from left to right. First the username and then the password. We then call execute. That will actually send the prepared statement to the database. We can use statement bind result to pull the column result into a particular variable. We'll call statement fetch, which will actually pull the data into the user ID variable. The bind result is really just a declaration to say this is where we want it to go. And now this user ID will contain the value that we expect it to from the database, and we have not endangered our application. This is an example in PHP using MySQLi. However, many other languages and many other frameworks operate very similarly to this. What you want to be looking for are prepared statements or parameterized statements. And what the magic is really doing behind the scenes is it is in fact taking this variable and filling it in this question mark. But it's telling the database specifically the value that we're putting here, it's a string. It is not meant to be executed. When the database sees that, it obeys. And so what you would end up seeing is our payload looking like a username. So if I tried to put in my SQL injection payload, the prepared statement, even without quotation marks in our SQL statement, the database would look at this whole string and see it as just that, a string, and not as executable SQL. I hope this was enlightening, and I hope to shed a bit of light on some basic SQL injection. I hope that you download Juice Shop. It runs in a Docker, so it's very easy to spin up. Try it yourself. And join us next time when we talk about some more advanced topics, including advanced SQL injection and other related topics in the OWASP Top 10. See you then.